A function f consists of a set of input x, a set of outputs, we call it y usually, and a rule for assigning each input to exactly one output. So this function f of x equals x squared is just a rule. It tells us whatever number you put in, the output is square of that number. For example, if you evaluate f of 3, it's just telling you to do 3 squared. So y will equals 9, or f of 3 will equals 9 in this case. The graph of a function is the set of all points x, comma y that is associated with the function. Now, when you evaluate a function f of x plus h, it's not a number, so the output will be an expression. And in our particular case, the rule is telling you to square the input, so we just square x plus h. And if you want to expand it, it's just x squared plus 2x times h plus h squared. The set of input, we will call it the domain, or simply denoted by D, and the set of output, we call it range, and we can denote it by R. And we learned from pre-calculus there are 3 restrictions when we're talking about the domain of a function. So the first restriction is if you have a function such as 1 over x, whatever is in the denominator, in this case is x, cannot be 0. So the domain for this function is negative infinity to 0, union 0 to positive infinity, or you can say all real number except 0. The second type of restriction is when you have a square root or an even root of an expression, and the expression under the radical sign has to be non-negative. So the domain in this case will be from 0 to infinity. And the last restriction is when you have natural log or any kind of log function, the expression where you're taking the log, that expression must be greater than 0. So for example, if you want to find the domain of the function f of x equals square root of x plus 1, well, take a look at the restriction. We have the second type. So whatever expression under the radical sign, in this case is x plus 1, must be non-zero. So we solve for this inequality to get x is greater than or equals to negative 1. So we will say the domain for this particular function is from negative 1 to infinity.